Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about Routh Stability Analysis. And this is linear control systems, example number 1. Lecture series on linear control systems, lecture number 32. So this is example 1 by using Routh Stability Analysis technique. Solve example Routh Hurwitz Criterion. Example 1. A closed loop control systems has the characteristics equation given by s cube plus 4.5 s square plus 3.5 s to the power 1 plus 1.5 equals to 0. Investigate the stability using Routh Hurwitz Criterion. This is the third order polynomial equation. Determine the stability by using Routh Hurwitz Criterion. Solution. Step 1. The given characteristics equation is s cube plus 4.5 s square plus 3.5 s to the power 1 plus 1.5 equals to 0. So what is the order? This is the third order systems. This is the third order polynomial equation. And the coefficients of s cube. This is the s cube coefficient is 1. And s square coefficient is 4.5. Similarly, s to the power 1 coefficient is 3.5 and s to the power 0. This is the s to the power 0. So s to the power 0 coefficients 1.5. 1.5. So necessary condition. Next step, necessary condition, step number 2. What is the necessary condition? Let us consider a system with characteristics equation again, s cube plus 4.5 s square plus 3.5 s to the power 1 plus 1.5 equals to 0. It can be stated that the necessary condition for stability of a system are as. What is the necessary condition? The characteristics equation, that means s cube plus 4.5 s square plus 3.5 s to the power 1 plus 1.5 equals to 0 polynomial have all the coefficients real and positives. That means s square coefficients 1, this is real and positive. S cube coefficient, similarly s square coefficient 4.5, this is also real and positive. S to the power 1 coefficients 3.5, this is also real and positive. S to the power 0 coefficients 1.5, this is also real and positives. So this is satisfied. First condition satisfied. Then second condition, none of the coefficients of the polynomial is 0. That means no missing power, none of the coefficients. S to the power 3 s square, s to the power 1, s to the power 0s. So none of the coefficients of the polynomial is 0. None of the powers of s between the highest and lowest power of s is missing. In this polynomial equation, no missing power because s cube, s square, s to the power 1, s to the power 0. So this is the necessary conditions. So this is the power s cube, s square, s to the power 1 and s to the power 0. The necessary conditions are satisfied. Necessary conditions are satisfied because all the conditions satisfied. It is to be highlighted that these are only necessary conditions but not sufficient. Not sufficient. All stable system must satisfy these conditions but system satisfying all these conditions need not be stable. So necessary condition satisfied. In this case, necessary condition satisfied. So necessary condition are for stability. Necessary condition for stability. The necessary condition help us to eliminate polynomials with negative coefficients or missing power of s by visual inspection only. This is the very important sentence. The necessary conditions help us to eliminate polynomials with negative coefficients or missing power of s by visual inspection. And next point, if the characteristics equation satisfies all the necessary conditions, it is possible nominee for examining further for stability. A Hurwitz and E.J. Routh have independently established the conditions for stability of a system without actually finding out the roots. The criteria is known as Routh Hurwitz Criterion for the stability. This criteria determines how many roots of the characteristics equation lie in the right half of the S-plane. So this is also very important sentence. The criteria determines how many roots of the characteristics equation, given characteristics equation, lie in the right half of the S-plane. This test also determines all the roots of the j omega axis so that their multiplicity can be found out. The polynomial coefficients are arranged in an array called the Routh array. The polynomial, that means given polynomial equation, third order polynomial equation, the polynomial coefficients are arranged in an array called the Routh array. So what is Routh array? So next steps, sufficient conditions. Sufficient conditions, Routh stability analysis. This is step number 3, and the polynomial characteristics equation s cube plus 4.5 s square plus 3.5 s to the power 1.5 s. This is the equation number 1. The Routh array is constructed as follows. Each row is identified in the descending order of power of s. The first row contains coefficients of alternate power of s, starting with the highest power s cube. So this is also very important sentence. The first row contains coefficients of alternate power s, and the starting with the highest power s cube. So this is the starting s cube. The next point, the second row contains coefficients of alternate power of s, starting with the second highest power s square. In this equation, s square is the second highest power. So this is the second row starting point. The others row are constructed in asymptotic way as indicated in the procedure given below. So step number 4, arrange all the coefficients of equation 1 in two rows. Row number 3, this is the s cube and the coefficients, alternating coefficients, first coefficient 1 and the alternating 3.5. So this is the first coefficients 1. And the next coefficients this is the first coefficients 1 and the alternating coefficients, this is the alternating coefficients 3.5, and the row number 2, this is the starting from s square. So first coefficient 4.5 and the second coefficient 1.5. 5. This is the S square coefficients, and this is constant or s to the power 0 coefficient 1.5, s to the power 0 coefficients. So first row coefficient 1 and 3.5, and the second row 4.5, 1.5. Then the sufficient condition or Routh Stability Criterion, Routh table. Construct the Routh table. This is step number 5. So row number 3, SS cube coefficients, and this is the SS cube 1 and 3.5, row 2 S square, and this is 4.5 and 1.5. Then from these two rows, we then subsequent rows to the Routh array. This is row 3 S cube 1 3.5, row 2 S square 4.5 and 1.5, row 1 S to the power 1 A B, and row 0 S to the power 0 C D. So this is the row 3 and this is row 2. The coefficients, these coefficients and 3.5 coefficients, and this is the 4.5 and this is 1.5. So determine A, B, C, D by using Routh technique. So first calculate A. What is the value A? A equals to 4.5 into 3.5 into 3.5. Just cross multiplication. 4.5 into 3.5 minus 1 into 1.5. 1 into 1.5 divided by 4.5, starting 4.5. So what is the magnitude or value? 3.16. So this is A. A equivalent to 4.5 into 3.5 minus 1 into 1.5 divided by 4.5. Next, calculate B. Calculate B. What is B? 4.5 into 0 minus 1.5 into 0. That means B coefficient equals to B equals to 0. B equals to 0. So B equals to 4.5 into 0 minus 1 into 0 divided by 4.5 equals to 0. Then calculate C. C equals to A into 1.5 minus 4.5 into B divided by A. So calculate C. C equals to A. A means 3.16 into 1.5 minus 4.5 into B, 4.5 into B. B equals to 0, then divided by A. A means 3.16, and this is equals to 1.5. Then D equals to again 0, because A into 0 minus 4.5 into 0. For A into 0 minus B in D equals to A into 0 minus 4.5 into 0 divided by A equals to 0. So A equals to 3.16, B equals to 0, C equals to 1.5, and D equals to 0. Put here A, B, C, D, the value of A, B, C, D. This is the final table, Routh Stability Criterion, final table. What is that? This is step number 6. So this is A 3.16, B equals to 0, and C equals to 1.5, D equals to 0. This is the A, this is B, 1.5 equals to C, and 0 equals to D. So what is the conclusion? A equals to, already calculate, A, B, C, D. This is the final table, A, B, C, D. Then conclusion for stability, Routh Stability Criterion. Necessary and sufficient condition from Routh table. From Routh table, determine the necessary and sufficient condition. This is the Routh table, final table, or from Routh table, this is the first column. First column elements 1 or entry 1, 4.5, 3.16, 1.5. So 1, 4.5, 3.16 and 1.5. These are all coefficients, first column. Then for a system to be stable, it is necessary and sufficient that each entry in the first column, that means this is the first column of Routh array constructed from the characteristics equation, be positive. In this table, 1 positive, 4.5 positive, 3.16 positive, and 1.5 positive. So satisfy necessary condition and sufficient condition, and this system stable because all the coefficients of the first column positive. So Routh stability, this is the step number 8, stability analysis from Routh table. This is the final table. And what is the conclusion? In the first column of the Routh array, there is no change in sign of the elements. Hence, there is no roots of the characteristics equation with positive real part, and the system is stable. This section very important. Routh array, there is no change in sign of the elements. Hence, there is no roots of the characteristics equation with positive real part. If this is the real axis and imaginary axis, this is real axis, and this is the imaginary axis. In this case, all the poles left hand side of the S-plane, all the poles left hand side of the S-plane. That's why this system stable, and no roots of the characteristics equation positive real part in this section, no roots. So this is the stability. Thank you.